Good morning. Our last lesson of the quadratics unit is solving quadratic inequalities. Before we can start quadratic inequalities, though, we should review quickly linear inequalities. So let's just review. If I had asked you to solve something like 3x is greater than 9, you treat this as an equal to sign. In other words, you solve in the normal way. You divide both sides by 3, and you would get x is greater than 3. Now to transfer that to a number line, you put 3 on your number line. It's not equal to, so it's an open bubble, and you shade in the direction of greater than, which is to the right. And that would be your complete response, or your complete answer. Similarly, if I asked you to solve something like negative 5x is greater than or equal to 10, you would divide both sides by negative 5. And when you divide by a negative, it switches the inequality. Also, if you multiply by a negative. So here I'd get x is less than or equal to negative 2. I'd put negative 2 on my number line. I fill in my bubble because it's less than or equal to, and I shade left for everything less than. And so that's summary. If you have greater than or greater than 2, you shade to the right, and means the word or. And we'll talk especially with less than or equal to, you shade to the left, and that means the word and. If you just have less than or greater than, it's an open bubble. If you have less than or equal to or greater than or equal to, it's a filled in bubble. So that's a real quick review from earlier classes of solving and graphing inequalities. So let's talk about quadratics now. Our first example will be to solve x squared plus 2x minus 3 is greater than 0. Well, first of all, just pretend, like we did in the beginning, that this greater than is an equal to sign, and solve as usual. Certainly factor if possible. And this is factorable. So I factor the two numbers that multiply to negative 3 and add to positive 2 are positive 3 and negative 1. And I can put those numbers directly in parentheses without splitting the middle because my a value is 1. Now, if this was an equal to sign, we would set both factors equal to 0 and solve. We don't want to write equal to because it's not, it's greater than. But we can certainly use the same idea for the roots. So if you think about x plus 3 being equal to 0, x would be negative 3. And if x minus 1 were greater or equal to 0, x would be 1. Now, from this point, we need to use what we know about inequalities and put them on a number line to figure out a result. So right away, after I've factored and figured out roots, I make my number line and I plot both numbers and I put them in the proper order. Here I happen to factor in the right order. Negative 3 is less than 1, so it's to the left of 1. I have a greater than 0, so my bubbles on those numbers will be open. They're not equal to. And then there are a couple of ways to approach which way to shade. The way I like to think of it, as I said earlier, is that greater than means the word or. And when you see or, that means we can't combine answers. You can't have both. So in other words, I can't be both greater than 1 and less than negative 3. That doesn't work. Another way to think of that is when you see the word or, you shade out. So greater than means or means shade out. And that's how I remember this. It's just the way my brain works with quadratic inequalities. So to finish this up, because I have a greater than, it's an or, and I'm going to shade out. So I'm going to shade away from each other. So I'm going to shade all things less than negative 3 and all things greater than 1. And then I need that. So I would say x is greater than negative 3 and use the word or. X is greater than 1. Actually, hopefully you just caught my mistake. This is everything less than negative 3. So it's x is less than negative 3 or x is greater than 1. There are no such numbers that are both less than negative 3 and greater than 1. Nothing exists. Now, If that's confusing, you can always plug numbers in. And what a lot of people will do is say that. They'll say, draw your number line with your -3 and your 1 with your open bubbles, and then plot some points on all sides of it. So maybe you'll substitute in -4. Maybe you'll substitute in 0, because that's between -3 and 1. And maybe you'll substitute in 2. And then you shade where it works and you don't shade where it doesn't. So if you substitute -4 in to the original, we get 16 plus 2 times -4 is -8. So 16 minus 8 is 8, minus 3 is 5. Then you'd say, is 5 greater than 0? Absolutely. So I have to shade this way. And then you would substitute in 0. 0 squared is 0, plus 2 times 0 is 0. 0 plus 0 is 0. 0 minus 3, -3 is not greater than 0, so I can't shade in there. And then you would plug in 2. 2 squared is 4, plus 2 times 2 is 4. 4 plus 4 is 8, minus 3 is 5. 5 is greater than 0, so I shade that way. So either way works. For me, it's a time saver to know that greater than means or and shade out. But if that doesn't work for you and you can never remember it, sides of points, and see, you need to be able to check on your calculator. And when you check on your calculator, you're just going to replace your 0 with y, because we're going to look at a graph. So on your calc, you're going to say, and y always comes first, or f of x, y, and this would be the y, and the points pointing to the y, so y is less than x squared plus 2x minus 3. And let's look at that. Okay, so here we are on our calculator page. Let's just do a quick sketch, scratchpad graph. And now we're going to graph y is less than. So what you need to do is delete this equal to sign. Just delete. And it automatically asks you, well, what do you really want to do? And we want to graph a less than. And it changes to y for you, because this will not be a function, because we're going to be shading, and it will fail the vertical line test. So we're going to graph y is less than x squared plus 2x plus 3, minus 3. And there it is. You should not be surprised that we're shading below, because when we go to graphs of inequalities, less than means shade below. And sometimes it looks a little weird to have it below here, but it truly is. That's not really what we care about right now. What we care about right now are those critical points. When we solved this algebraically, we got x equals -3, which it appears to have right there, and x equals 1, which appears to be here. And notice the shading is outside of those critical points. I've shaded out here, and I shaded out here. Equal to self minus x minus is less than or equal to 0. Once again, this is factorable. I'm showing you two factorable ones for the process today, but do keep in mind factorable formula. But again, just for the sake of time, we're going to do this. So what I would like you to do right now is try this. Pause the video, factor it, think about the way it would shade, and check it on your calculator. I'll go through it also, but there's no sense watching the entire video if you understand. So pause, try it on your own, fast forward to the result and see if you got the same thing, and if you did, then you're all set and you can go to the last example, which is a little different, so make sure you do the last example. Okay, so this is factorable. X minus 2 and x plus 1 multiplies to -2 and adds to -1, and so my factors are 2, or my results are 2 and -1, but it's an inequality. I'm going to place -1 to the left of 2 on the number line, because that's where it lives. And this is less than or equal to, so I shade, I fill in my bubbles. And because it's less than, that means and means shade in. So I'm going to shade in between those bubbles, which means my result is, you could write it two ways, x is greater than or equal to -1, and less than or equal to 2. Or you can use the word and if you don't like the inequality to look like that. So you could say x is greater than or equal to negative 1 and x is less than or equal to 2. There is your result. Once again, if you're not sure how to do that quickly, you can certainly plug in numbers on either side, maybe 0 in between 1 and 2, negative 2 to the left of negative 1, and 3 to the right of 2, and see which numbers work. Negative 2 will not work, 0 does work, so you shade there, 3 does not work. Then check it on your calculator. So for our last example, we're going to talk about solving a system of quadratic inequalities by graphing. You are absolutely allowed to do this on your graphing calculator, and I suggest you do so. Just keep in mind, when it comes grading time, we can't grade your calculator or your head, so you need to show some work. You need to be able to transfer what you see on your calculator to graph paper, and we'll talk about that. But let me just show you the solution quickly for sake of time on your calculator. I'm going to add a graphs page, and the first graph is y is less than negative x squared plus 3. Now you should be thinking, ooh, parent parabola, upside down, up 3. And there it is. Now we've shaded below because it's less than. If you look at this carefully, kind of hover on the graph and right click, which is control menu, you can make it look more broken than it does at first by making that line weight thick. Our second graph, so let's tab to get to a second equation, is y is greater than or equal to x squared plus 2x minus 3. Because this is in standard form, I can't see the transformations. I might think about how it opens with a y-intercept of negative 3 and get a axis of symmetry here. But here are both of my graphs, and this is a solid graph. If you really want to see that again, right click, control menu, make that a fat line, and you can see that it's not broken like the other one. Just like when we solved linear inequalities, the solution is where the two sets of shading meet. So when you get this on graph paper, it's this dark shaded area that is your solution. So to get this on graph paper, a couple of things. You can do it the old-fashioned way with axis of symmetry and all of that. If you want a table of values, you can't get a table of values with inequalities because there's an infinite number of points in here, and so you would have to change these to functions, and then you can do a table of values. So really it's whatever you understand best. But coming back to my paper real quickly, you need to be able to transfer to graph paper something like this. So again, if you want a table of values, you would change these to functions equal to signs to get your table and then know all your rules. Or if you don't want to use your calculator at all, you can remember your transformations for this guy. You can remember what to do with parabolas in standard form with this guy. And all the shading rules, above for greater than, below for less than, solid for equal to, broken for not equal to, apply to any graph, not just lines. But just make sure that you can graph these both on your calculator and transfer the answer quickly to graph paper to be graded. That's it. See you tomorrow.